All right, good morning, everyone. I hope you guys can see my slides. I'm Professor Tan. I'm the director for the Center for Reliability Science and Technology, a subject that not many people are familiar, but it's a subject that's very important today. Not only today, but it keep becoming more and more important. And that is my email and my website. And I'm originally a professor in Nanyang Technological University in Singapore. I'm a Singaporean. And in 2014, the chairman of Chang'an University invited me over to Chang'an University to set up this center, which is the only center in Asia doing reliability work. I've been doing this work for more than 33 years. And so you can see that this is not a new subject, but it's becoming important. And so it's especially for developing country, there will be even more needed. Okay, so well, where is Chang'an? Chang'an University is, if you go from airport to Taipei, you will definitely pass through Chang'an because it is in between. All right, and so although there's a but this is our university on the top, and so the center is consists of many things, and I have initiated a joint program with National University of Singapore. I also initiate a dual degree with the Singapore University of Design and Technology, because I came from there and I know the university very well. So students that join me can have a chance to go to National University of Singapore or to go to the Singapore University of Technology and Design to do the internship as well. And so there's a vast opportunity that you can not only experience Taiwan, but you also can experience Singapore and be in the world-class university there. All right, so okay, so I'm actually a committee member of IEEE Reliability Standard Working Group. I'm in 2 and now in 3 already. I'm the one who writing the international standard for reliability in IEEE. One is a 1624, which is a standard for organization reliability assessment. Another one is the 1431, is the reliability prediction method. I'm also a committee of IEEE Electron Device Reliability Physics. And for those who are electrical engineering, you know IEEE is one of the is the world's largest organization for electrical and electronics. I'm also editor of several journals, as you can see, and there are many more, but I just list out a few. Now, Center for Reliability Science and Technology, in short called CREST, is the only reliability center, only reliability science and research center in Asia. There are many people working on reliability engineering, but working on reliability science. They are quite different. In fact, I'm the founder for this discipline. And in fact, we are also the world partner for Infineon, which is the world #1 automotive power semiconductor industry. We are the only one in Asia which is selected by them to be a world partner, business partner for that because of the reliability work. Now, there are many projects I have with the industry. Okay, NASA, probably you guys heard of it. I'm working on it, and we are going to publish a paper soon. And TSMC, also I'm working on TSMC on the radiation on semiconductor. In fact, one of my students graduated this year. Immediately, without his application, he got accepted by TSMC without even submit the resume. And Light-On Power is another Taiwan power semiconductor company, and I has a 3 years project with them to help them to solve the industrial problem. I'm also invited by the Singapore Land Transport Authority to look at the lifetime of their car, the bus card reader. And I'm a consultant for SGS Taiwan. SGS is a company, is a Swiss company doing the reliability testing and certification for many different companies. I'm also doing a project with Infineon China using radar to do some biomaterial analysis. And I'm also a consultant for MATech who actually doing is the world number 1 or 2 on the reliability test and analysis as well as failure analysis. And I help them in a lot of reliability analysis. All right, and there are more. The NBI is a company, Taiwan company doing the LED driver, and I have a 3 years project with them, which is already over, to look at, help them to do an IC design so that they are reliable and also to evaluate the reliability of that. GTech is a power industrial computer company. I help them to look into how to incorporate reliability into that. Epistars is one of the world's largest LED company. They're producing LED. I got to work with the failure mechanism identification. In fact, one of my students just recently recruited by them because of our work together. Kemen is a company that's doing a lot of software work and final analysis and so on. I'm a consultant to help them to use their software for reliability analysis. There's another company, it's in Chinese name, is doing the gallium nitride. Moxa is a company doing all the internet for over the whole world. And I'm the consultant to help them to incorporate design for reliability. Cetera Malaysia is a German company in Malaysia, which I do some reliability tests for them. So you can see that there are so many, in fact, many more are coming. And the student that joined me in TIP basically will have a chance to work with this industry. All these are the big industry. And so they are able to do the real work and also to be able to experience them in a different way. Now, the reliability that I do, in fact, is quite wide in scope. Is including material reliability, looking at the reliability of material, looking at reliability of devices that include electronic, electrical, and mechanical devices. In circuit reliability, looking at how the integrated circuit or even discrete circuit to improve their reliability. System reliability is to looking at the reliability of an entire system. For example, I do a work on the reliability for the wind turbine for Denmark company. I do a reliability for aircraft for Singapore. Presently I'm doing a reliability for the whole oil and gas industry air compressor plant. So these are we are talking about very, very big things. And so my center is a one stop from material all the way to system. And of course, I also do reliability improvement. That is to improve the present product so that they can improve their reliability and therefore to be able to compete in the world to help the Taiwan company as well as other companies as well. You see, reliability is not many students heard about it, but in reliability is very important. Why it is important? Because we all live in a globalization. And a customer today, like you and me, buy things from all over the world without traveling because of internet. And therefore, why the company will choose a certain brand depends on the product value. And product value, according to the American Society for Quality, is defined as a customer perceived value over the price. And what's customer perceived value? Well, customer perceived value will be the value that the customer feel like it has a value for the product. They include the performance as well as the reliability for the product, meaning the how durable this product can use, how long it can be used. So both the performance and how long it used is customer perceived value. Now, price is a denominator, and so people will compare prices. In fact, there are websites that will help you to compare. So in other words, you can see from this simple formula that achieving high product reliability at reasonable cost is a key success factor in today's electronic industry. German product is very good in reliability, but the price is high. And US product, the price also moderate, but the value may not be good. And so what happened is that you have to trade off between the good reliability, good performance, and a reasonable price. In fact, I've been invited by Germany in many ways, in many times, and that's Infineon, a German company, to teach them how to incorporate reliability into their product so as to improve the value. You see, every product you have a supplier on one side. And so we just need to align. And therefore, you can see that the product and process, whether the customer will need it or not, depends on whether they meet the need. And their product they sell but got problem, like for example, Toyota. And so in fact, people survey that what are important. In fact, at 2010, people has done, today people buy things from from internet. So what is important is if the American study for quality survey, product availability, meaning that when you want to use the product, it is available. So that's product reliability. You order things from the computer system reliability is important. Everything is delivered, the package reliability is important. In fact, reliability is everywhere in our life, except no one talking about it. It is needed, we need that, but people don't do that. As you can see, therefore, the key success factor is really four: price, service, reliability, and time to market. And so these four, like the four legs of a chair, it make it very stable. And today, people want to reduce the cost while improving reliability, improving performance. That is a challenge because that's what Germany cannot do. And why it is so? Because there's so many, because as the system becoming complex, the reliability also reduces, as you can see from this table here. I don't have time for that. So you can improve the performance by getting more expensive product, getting redundant. You improve the performance by having the product smarter, more complexity, but this will reduce the reliability. You can improve the reliability by more parts, higher, more expensive part, but this will increase the cost. But as you see, that what is challenge is that you want the low cost, get improved in performance and improve reliability. That's where reliability science comes in. So current reliability study, basically, if the product has to be made first, do the testing, then they know the problem. That is too late. That's too costly because redesign needed. What I have introduced a reliability science where I can do the reliability by looking at the reliability physics, looking at the reliability testing method, reliability statistics, so that I can predict whether the design is good, whether the manufacturing is good to produce a reliable product. So in this sense, I need people from all over the different disciplines, from physics, quantum mechanics, for example, from device physics, from chemistry, because material degradation need to do analysis, material, statistics, industrial engineering, electrical, mechanical, and computer engineering. All these are needed in my center. In fact, my center has all these people. Now, reliability is so important that you can see that in the survey in 2019, you can see that among all the engineers, different type of engineering title, only software quality engineering and reliability engineering has the highest salary. In fact, this year 2020 came out, turned out the reliability is even the highest than software quality engineering. Companies like to pay so much because it is important, but it is very few, they can find very few students who have the expertise in reliability engineering. And this center provide the training. And we have many facilities. Okay, so we can do all the reliability work. You can see that. And these are my students that graduated from me. If you can look at that, most of them are either the TSMC, or they are in STMicro, or they are in Intel, in Google, and this name, you know it. And so these students, most of the students of mine, basically are able to get a job even without applying. Because they publish paper with me, company go to them and get them right away. This is the part of the team. You can see that most of them are Indian students, and I got many Indian students, and so we can actually provide this training, and there are many big jobs are lying, waiting for you guys. Thank you.
Okay. Professor Tan, just one question. Computer engineering and this computer engineering and computer science, they are same or not?
Well, actually, I need both. Computer engineering more on the hardware, computer science more on the algorithm and the software itself.
Okay.
In general, yeah. Yeah, the analysis need a lot of computer algorithm, data analysis, big data analysis. That's why computer science needed. A lot of hardware is computer control, and that's why we need computer engineering.